And this week, 25th to 28th of June, SSIT was formed 50 years back. So this is the 50th anniversary and they wanted to celebrate throughout the world. And in this week, we are conducting totally 11 such events where people will be talking and listening to the social implication of technology. So any technology like invention of steam engine or atom bomb or whatever, that is for that, anything is done for human being, and that has an effect. Like laptop, Intel has changed our life, how the computing has changed, how they have the impact on our society, our life, all those things. So it's like similar things are happening. 11 geographics, and there are 11 talks are happening. Some of them are like this in person, some of them are online, some of them are hybrid. Like that, we are celebrating 50 years of the formation of SSIT. And our today's topic, I take very like privilege to introduce our esteemed speaker, Dr. Ananda Mohan PV. He is the life fellow. So fellow is like only 0.1% of IEEE members who has raised to a certain level as an expert in their field. But he has retired, but he has spent his entire life in electronics, communication, semiconductor, and all those allied fields. And he will tell us, share his journey, his life, how he has observed that this technology, this field of technology has changed humanity, our life, his life, his surroundings, what happens, some stories, some people what they told when something new came, radio came, television came, maybe like that, I don't know. But we'll hear some stories and some technical aspects also, how thing happened, why thing happened, what was the need to invent something, and also if he feels that some innovation could have been done in some different ways, that would have been better for humanity. This is our expectation, but he is free to talk about anything, sharing his life journey. Let me welcome sir. And now you can.
It is a pleasure for me to address all of you, and I am the oldest here. So I am 77 years old, and I had, I tell you, I was born in a village, Andhra Pradesh, Attili. Okay, then studied in their school up to SSLC. Then for college I had to go to another place, slightly district headquarters, Bengaluru. So I studied PUC. There in those days only 1 year, pre-university. Then I was underage actually, because at the age of 12 I passed PUC. So no engineering admission was feasible. Then then instead of sitting idle, my parents told me I don't to join BSc. So I joined BSc. So and I didn't take chemistry. I took only mathematics. One mathematics, two and physics. Then after BSc again, I wanted to go to IASC for. They used to give BG after BSc, IASC, but then also I was underage. Then this I thought, why don't I join MSc? Then I went to Visakhapatnam. Then MSc technology was there. It is actually called applied physics. So, but applied physics, interestingly has all engineering subjects. We used to read applied mechanics, applied electricity, then applied optics. Okay, so a workshop practice we had, geometrical drawing, machine drawing. So that means it is more or less like the engineering course. So I have done that. Then afterwards I tell you how the trajectory has gone. Okay.
Is it on?
No, it will work with, I think, with the television only.
No, no, it's
Oh,
okay.
it's working. Okay.
Okay, so see, actually, after that, being MSc Tech, I had joined as a research fellow, junior research fellow, and I was actually working in some area, thin film laboratory. Actually, in those days, technology was developed in India. That means, only in Bengaluru, actually, one company used to be there, advanced high vacuum company. Here, high vacuum company was there, high vac. So they used to make all this vacuum equipment and all. So now, problem has come. My supervisor told me, I want to measure the thickness of a film. For example, all these bangles, mirrors and all, what they do is they put a substrate and then they evaporate metal, like in aluminum. Aluminum means it will form a mirror, that will put proper thickness. If it is not proper thickness, it will not be a mirror. That is semi-reflecting, will be there. So that means how to measure the thickness. So that was the problem. So then what happens is, actually the filament, when becomes white hot and red hot, then it melts aluminum because there will be a crucible. What happens is, how do you measure the thickness? You have to only reflect light and then measure. But this is the noise actually. Because filament itself is so hot, So now how to distinguish these two? Then I need to go to this library of Ananda University, which is an outstanding library there in those days. So then there was one technical modulation.
So what year are we talking about?
Pardon?
What year are we talking about? 1950, 55?
That is 19, no, it is not 1950, it is 68.
68.
68. So then, we had to invent some method, then somebody has found that suppose I chop the light, then let it reflect. That will be like signal, and this filament light is noise. So you have to put a bandpass filter and then eliminate that noise. Okay? So that was in those days I have done using vacuum tubes actually. Because no transistors were available in India. Only something like point contact transistors used to be there. So I built a hardware using vacuum tubes, and then this light, you measure using something like photomultiplier. That means it multiplies that light, whatever comes, current is produced, then multiplies. So that we will pick up and then we will filter that. And then we need to calibrate, telling for this much thickness, for how much reading will come, how much reflectivity will be there. So like this, this was done, and then actually my interest in analog filters has started. Okay, and nobody was guiding or anything. I used to go to this Ananda University library, and we used to read a lot of books like journals, like Review of Scientific Instruments, Journal of Scientific Instruments, and then I got my own. Then later, I fought with my guide there. That is my supervisor. So then, I had to. He told you get out immediately. Then, luckily, in those days through employment exchange we used to get a job. I got job in Naval Science and Technological Laboratory. That is actually one is in Cochin, NPOL they call. So this was a branch of another laboratory in Visakhapatnam. Then I was the actual first employee there. Then, there is a lot of freedom actually. That is, I can get any transistor I want, anything like that. So I started working on something like using transistors and building some oscillators and all, relaxation oscillators. Okay. So that was the first one. So that means the freedom was there in those days to do our own research and all. Then, but I was not happy there because I was getting 210 basic in those days, 210 basic pay, and total around some 390 rupees or something I used to get per month in those days. So then problems, family and all that. Then, but I was very keen in doing PhD. So I applied to Indian Institute of Science, Bengaluru, and then the very big panel of professors were there. Okay, then they asked me explain this because Professor Sonde was there. I don't know if you heard about him. He is one of the most outstanding professors. Later he started that CEDT, Center for Electronic Design Technology, and all. He has written 6 books in those days for Tata McGraw-Hill. Okay, on something like broadband amplifiers and all. You know, people used to curse in those days when you used to teach. Why he is teaching us all this? But today it has become a craze. RF CMOS is nothing but that only. So that means those days all techniques were known. Only technology was using bipolar. So this now of course CMOS has come. CMOS RF has come. So that was what he used to tell us. Why don't you? Then he interviewed. Then there were other professors also, M.T.A. Raju, so many distinguished professors were there. Then I was selected. Then then he told me, because I worked in some negative resistance device for relaxation oscillator, he asked me, why don't you work in negative resistance? So my thesis was negative resistance in bipolar transistors. That means actually I am a semiconductor fellow from the beginning actually. Then someday I had the opportunity, he used to visit Japan. He was working as a postdoctoral fellow in Japan and all. So a lot of transistors he has got, like different types of technologies, LID fluid, epitaxial, planar epitaxial. Then like this, so many types of transistors. So he used to give me and then say, study the characteristics of this. And the study actually is very sensitive because I have to do investigations in the breakdown region. Breakdown region means I apply apply a very large voltage to the transistor. It should not die. So he asked me to study the properties, you should build a pulse test set. So pulse testing, so I have to build my own hardware to give this very high voltage pulses like 150 volts pulse, and then a very short duration of time. Then see what happens. So all the curve tracers and all could not be used because they give continuous power. Hewlett Packard and all, they were having some curve tracers and all. So I have to build my own test set to this test the transistors. Okay. So 3 years. Then at the end of 2.5 years, he asked me to start writing thesis. Then I asked what I have done. Then he said, now you will do. That's what I was telling morning somebody. Because when you start writing, your pen will not move. Because that means you find there is something, you are unable to explain something. So that's why what happens is, that's how, then you have to do a lot of experiments. And every day evening, I used to meet him. He used to tell me, whatever time it is, I will call you whenever I am free. Every day 6 o'clock we used to meet. Every day I used to miss my tea in ISC hostel. Wait for him. Then he used to talk for half an hour. We used to talk. He used to ask, Karan, what happened yesterday? Something I asked you to do. Then I used to give him feedback. Then sometimes I say that won't work. Whatever some idea he was told. Then he used to say, evening times you get such ideas only. Okay. So anyhow, but I cannot laugh. I cannot laugh. So that's how, but he was a very meticulously, he used to guide, and then he used to like me very much. Then he said, you submit thesis. So at the end of 3 years, I submitted. But then I asked him, why don't you get a faculty position in ISC? Then he said, no, this is not for this is not for our students. Okay, I want you to go to industry. Then he said, why don't you apply to ITA, Indian Telephone Industry? So then advertisement came, I applied, and immediately they gave me a lot of increments in those days, 400 basic with 9 increments they gave. Okay, then imagine there, actually in those days, the boss of ITA was a telecom fellow from this PND, because it comes under a PND. But one Sachdeva was there, he was a knowledgeable fellow. Then he told him, you have worked in negative resistance devices, why don't you develop a switch for me? Crosspoint. Crosspoint means, you see, before that people were using only Strauser and crossbar exchanges, which are all, metallic, a lot of relays and noise used to make and all that. But they are very good. Sound used to be very good. So, electronic crosspoint matrix You have to design. So use your expertise to design a particular device. So I have made one device using transistors in a particular mode, inverted mode we call it. Inverted mode means collector and emitter interchange. Then I connect two transistors, NP and PNP, and make like a PNP diode, which we call today SCR. SCR silicon control rectifier. Made a diode, and then this we made a big the PCB containing the 700 switches. Because there is a 50 line action, 7 simultaneous cards could be made. So 700 switches, PCB, all control electronics. Then space was big because the number of cards were more. Then we got it fabricated in encapsulated. Then both transistors moved together, encapsulated in one package by CDIL, Continental Devices, India Limited, Faridabad. Okay, and
So when did CDIL start and is it still working?
no, afterwards it has gone.
It's gone. So we don't really have any semiconductor at that level.
CDN is still there.
Okay, so that's why got it fabricated. Then ITA, first exchange we established in this Graphite India Limited. In this
Okay, very good.
Graphite India. So because 50 line exchange. Then later, this Palghat factory was started. ITA Palghat was started exclusively to make electronic telephone exchanges for field. Okay, that is all PAX. PABX nahi hai, wo PAX hai. So that, like that, we have done. So that means, we had the interaction with industry and tried to make products and all that. Okay. So, when I submitted this page, at that time I'll tell you technology available. No airmail. Everything you to go by Gmail. Thesis has to be sent by Gmail. And thesis, 6 copies you have to get by something known as one stencil used to be there. On that, one special typist used to type all that. Correction you used to make with some correcting fluid. Only 6 copies, you can ammonia print the card. So 6 copies. And drawings, this we had an expert draftsman. So the draftsman used to draw the drawing on tracing paper. So that he can take that ammonia print copies. Only 6 copies you used to get. Beyond that you used to get smeared and all. Okay? But still, outstanding work used to be done. How? There was no Xerox machine. I used to go, myself and my colleagues were there, one going there, all, he was in this one, GATEC, he was the director of GATEC, Hyderabad. And so all these, we used to sit in the library, and we up to, say, 9 o'clock every day. And then we used to write down in big bound volumes, because they never used to give to home also, all these bound journal volumes and all. We have to write with pen, enter whatever points are there. Go home. So this is how, but creativity was there. Because you see what I'm telling you, necessity is the mother of invention.
Exactly. That
So,
is the key.
if today you are having a lot of comfort, that's why output is not there. Output in some sense I am telling you. I am not telling you are not producing an output. Generally I am telling you, creativity, patent production, all this, why it is not there? Because, people have become morons. Some points are there, I will tell you that. So, delay, paper, suppose you submit a paper. 1 month it is to take to go to that IEEE. Then reviewer, it has to go by post to reviewer. Then he will send after 1 month. So 6 months, For example, my thesis I submitted in August 31st, 1973. I got degree only in 75 June. Because reports have to come. Then some report somebody will say, change karo, something like that. Some clarification have to give. Clarification again have to go to that reviewer. At least 2 reviewers have to say this thesis should be accepted.
Again, you have to send by post.
Yes, postman. Viva Vasi. Then, so like this, Viva Vasi people have to come by train. So what I am telling you, these were the troubles. Today everything is at your disposal. Okay, so that is so society, that's why it's changed now. So months of delay to submit papers, receive reviews, revision, publication, all this. Then ITA, In fact, I tell you, today it may be in a very bad shape, but it's one of the best companies. Research and development, indigenous development was happening at a very great pace in those days. For example, we have built so many electronic, first microprocessor, when it was released in market, 8008, we have built an electronic exchange using that.
Then what happened?
No, I will tell you. That's why, no, I will tell you. You know Arambhasvara, Arambhasvara. Arambhasvara means starting like all this we do. Afterwards we just lie down. Once you photos you take and all give awards, all this, Padma Singh and all you get. Afterwards you just sleep. That is what happened. Technology, you should never sleep. You should flow with the time.
The signal should not damp.
That is what mistake has been done. Okay, that all these points are there. So that's why you see when you put it on the net, please be careful because some adverse comments will be making. Okay, so you may have to delete some of those.
Sure.
Yeah,
I'll
maybe
send
I
it
will
to the
tell-
global. They will do whatever they will put.
Okay, so then our directors were so brilliant fellows. Sachdev, I told you, was there. Then Dr. Prabhakar, he came from IIT Delhi. He was specially brought to start this VLSI technology. So we have developed two tools. One is Chitra, Nirman. Nirman is for PCB layout. Like CADStar, today we are using, it was developed at that time. Then Chitra is for VLSI layout. And we have 3-micron technology. So he was a man of vision and he has developed a very strong group. Afterwards people have gone to industry. So then there was a lot of requirement for a design of compact electronic exchanges. There is something like subscriber line circuit. Because 8 subscribers we have to put in one card. And there are some functions like burst functions. Battery, origination, ring, pitch, codec, hybrid, test. These are the, how I remember, because we have that passion to know and to remember also. So that whole thing we have to build for each subscriber, all the actions that have to take in place, everything will be controlled by microprocessor, but all that is fully analog. So this fully analog, then PCM filters, then PCM technology came. PCM, first PAM came, pulse amplitude modulation. Even that needs a filter because you have to band limit the signal. Then only you can do coding or something, analog to digital conversion. So then filters came. You know who was the first filter company in India? MOS, Intel. Imagine Intel is a microprocessor wala. Intel has done the first PCM filter, 2912 in those days. Actually how it came, it was PhD work of a student from Berkeley. So they, that's how they funded this University of California, Berkeley, Professor P.R. Gray, Hodges, Broderson, told this is required in lakhs of numbers. VLSI should go only for such things, such requirement, which is lakhs. So then Intel has put some brilliant fellow and they have made the first PCM filter, the switch capacitor. So switch capacitor technology was a PhD work of one student of Hastika of this fellow, Broderson. Broderson was a fellow very long ago has become, is one of the outstanding analog designers. Gray is Dada, Paul Gray. Paul Gray, so many books he has written. Okay. All these students are outstanding. Gray, Alstock, then Hastika. So these are the pioneers in this. So then this, but at that time filters have been made. So we had a hybrid circuit facility in ITA. That means you can buy thick film pastes. So I can put in, then I fire that. Then it becomes a resistor. Then we laser trim into bring it to exact value. Then chip op-amps were there. Chip capacitors were there. So using these we have to build very complex filters. So we have built in our own facility here. Okay. Then ceramic substrate we take. You have to do all this layout, then you have to put those things, fire the resistors, then laser trim those resistors, okay, then package. So this was the whole thing was done. And very stringent requirements were there, like extremely low noise, because my FDM systems, what happens is army, this is for army actually. So they said 6 channel, one box they want. Till time division multiplication is not become popular. Okay, so army said, I want to send 6 piece channels should go. Bandwidth is limited, that is 4 kilohertz. So exactly 3.4 kilohertz, fatapat it should go to minus 70 dB. So how to design those analog filters? Okay, so very innovative techniques were there. How to avoid this complex laser trimming. Many papers have published during that period because everything was out of necessity. Problem comes, solve, publish. And in those days, procedures of IEEE used to be there. Even now it is there, but procedures of IEEE and letters from section used to be there. So that is only 1.5 pages. And acceptance time is 1 month. Go no go decision, yes or no. I published so many in IEEE proceedings in those days, that is from around 73 to 80. Okay, and I have visited this so many conferences, ISCAS conference. Okay, ITA used to sponsor. I was the only fellow who was doing research and publishing. People used to say, this fellow doesn't have any work, so he is publishing. Now, many companies in India, they feel if somebody publishes, he is wasting his time.
Correct.
Okay, but they sent me to discuss Rome, then Helsinki, Oregon, Portland, Oregon, Kyoto, Santa Clara. So I used to go present papers and meet very eminent people. In those days, see, for example, if I meet Sanjit Mitra or say Baras or all these fellows, you feel the radar and gold. They are all dadas in technology actually. So just to go and say, now you do for all Shahrukh Khan and all, but in those days, we used to do for all these eminent people, okay, outstanding researchers were there. They used to come to ISCAS, every ISCAS they come.
That was a very prestigious conference, ISCAS.
Okay, so this is how, every year on the other time, and then afterwards, what happened was, then I went to Canada. I was there for 3 years. Postdoctoral fellow. Then, she will tell you my experience. Before I went to Canada, these fellows, our Professor Swami, M.N.S. Swami is a very brilliant, very top fellow, he's a right fellow of CAS, okay, and best ever awards and all he got, Sydney Darlington Prize and all. So, I met them in IT actually, they came. Then I told them, I have applied to you a number of times, but you never replied. Then he said, you come, now you please send your application. Immediately, we will give you fellowship. Then they gave me postdoctoral fellowship. So I was there for 3 years. Before that, what they did, they sent me by post some papers on switch capacitor filters. I was scared actually, because I don't know ABCD of switch capacitor filters. I thought, I will become an idiot once if I go there and find me. They find me an idiot. Then that is how Indians work in USA and all, because you don't want to look like an idiot. Somebody should not say you are an idiot, So that's why, that I used to refer to some great papers, read, and that was fully on digital signal processing actually. But before the digital signal processing, of course, in ITA we have done, because we have built some DTMF receivers, dual tone multiple receivers, which read very good digital signal processing techniques and all that. So this I was scared, but then what I found was they also don't know anything. Because most of them, what happens is they hire you, they have the intelligence to get people and make them sit in some chair and table, and you tell them work in this area. That's all. I didn't meet them more than 2 or 3 times during the 3 years. Because that Ramchandran used to tell me, if you have any paper, please come to me, meet me, or give me. I will give to typist. That's what he used to do. But they are very intelligent people. That means the Swami is outstanding, and they are very good teachers actually. They were all from IISc. Ramchandran was Prabhat and Ramchandran were professors in IEEE, the network theory. So then we need to, sometimes what to do, some students, they just read the paper and they know immediately they will grasp the point. Because experience, because there are some doctors there. I have seen, he will not ask you, he will ask you to talk only. He will not use stethoscope. He will not touch you. How? He gets. He knows what is your problem. How he knows his intuition. Intuition means they will be studying your face, your movements, your way of talking. Then he says, this fellow must be having this this problem like that. So that is intuition. So what happens is sometimes they read the paper, cursory reading they do and say, suppose we have claimed this, then I think proving not convention. Or your comparison with previous literature is not sufficient. So like this, some comments they make. Other than that, for me even of course that contribution, that also was not there. Then at the end of 2.5 years, I told I want to write a book on switch capacitor filter because I felt there is no book available. Then oh, Karo, no problem. Then he said, after you go back to India also you can send it. So I came back to India. Then I sent it. Then again what they do, they simply give it to typist. And typist types. Again proofreading used to come to me. I used to correct and send back. But they got a very good publisher. Because they have a reputation. Prentice Hall London. So Prentice Hall London has published that book. That was my first book on, first comprehensive book on switch capacitor filters. You know how much time it takes to write the book? Because in fact I tell you, recently I met some Indian professors. That name I forgot, from Orissa. He was telling, I read your book, this particular chapter, to do my PhD work. N-path filters. Today it is a craze actually. There is something on N-path filters today. Because all other techniques are useless in that particular area now, especially in RF CMOS. So I have written a full chapter on N-path filters in that place. She was telling me, आप इतना अच्छा लिख दिया. I'm benefited only by that, he was telling. So like that, what happens is, that book writing, that means whole plan actually has to be there first in the brain. That is complete table of contents should be there in your brain. Then we build up. And there was no bias. That is, so many papers I have to read. I have to read them summary, I have to do, and some useless papers I have to filter out. All this, I have to. But that switch capacity, that was, So this, that is the only benefit I got. That means full freedom to do research in Montreal. Okay, I had full time for me to do research. Then afterwards, after coming back to India, then what happened was this, then afterwards what happened was this was since 74 I have been publishing. And most of the time I was focusing on non-idealities. Non-idealities means, is there anything ideal in God's creation? Suppose when you take an offhand, is it ideal? Children you can teach, telling RF by RA is the gain. Some bandwidth from megahertz. So, suppose I want to design a filter for some 40 kilohertz. Will it work? It will give some anomalous behavior. Why? Non-ideal to me. Like there is nothing like, there are so many parameters are there, like output resistance, input resistance, then second pole, first pole of the op amp, so many parameters are there. So all these things, now first you do theoretical analysis. You should not go to SPICE and go on simulating some curve it gives. Can you explain why it has given that anomalous behavior? So what I mean is, first modeling has to be done, then you go to SPICE. Don't start with SPICE in the beginning itself. So our whole work was all that only. That is some non-ideality is there. This I want to reduce this trimming of all components. Can I trim only one component? Because it will save me time. So precision tuning, how to do. So these are all actually problems which have been faced in practice and found solutions for all these things. Then later, this Radhakrishna Rao, from IIT Madras, Radhakrishna Rao, his group started something known as partially active arc filters. What they told is capacitors you want to avoid in filter design. So what he told is because why? Op-amp itself is having one capacitor inside. For dominant pole creation, they put one compensation capacitor. So one capacitor is already inside. Why you want two capacitors? You only one capacitor. That is only partially active arc filter. Then somebody told this op-amp itself is integrated. Because it is like because the bandwidth is falling. That is, gain is falling with frequency, means it is a filter only. So why do you want capacitor again? So that's how active arc filters have come. So that means like this innovation was there throughout the industry. Then we also have to jump with. Then technology sometimes will not survive. Why? Active arc filters is good, but performance is dependent on bandwidth of the op-amp. Can you control? You can't control. Suppose you take 10 741s, measure bandwidth. All will vary from 500 megahertz to maybe 1.5 megahertz, 500 kilohertz to 1.5 megahertz. So then people, and another thing, the temperature varies, bandwidth varies, power supply varies, bandwidth varies. So people thought we should not use active arc hereafter. Then switch capacitor. That's what Intel has. So they say it should be controlled only by the mask. Performance should be controlled by mask, ratio of capacitors. Absolute values, don't bother. That is how that whole BSI technology was based on that funda. Performance should be dependent only on ratios, not on the. So that is the contribution of that Intel, I was telling you, that Protestants group on California, Berkeley. So then
2901, you said something, right?
pardon?
2912. 2912. Intel. Filter. Yeah.
Then of course side effects will be there. Suppose now you put switches, you have to analyze only using DSP methods. When they started on, they were telling that this you charge a capacitor, then again discharge. So they said tau by C is the value. That is sampling period by C. But that is only approximation, because this is now like a sample data system. So the DSP comes into the picture. This is not possible. So that's how a lot of tools were developed. In fact, in Python also, they have modified the some equivalent circuit. For example, I need one delay, half delay, that power minus half. That power minus half, how do you model in Python? We have to put a 10 section delay line. Transmission line, how to put. But people like that, they have, because time domain simulation have to do. So like that, lot of tools, just so many tools, SCAP, switch capacitor analysis program, SwitchCap has come. Okay, so Diana has come. So like this, every big fellow in the world wants to say my own program I am developing for analyzing switch capacitor circuits. They have developed like that. Industry, people were using all that. So this lot of work. Then back to DIN 83. Then again our boss told Dr. Prabhakar was there. He told, why don't you design a sigma delta converter? Today it is a craze, people, analog people are there, somebody oversampled, you have to do converters. So in that, that is known as sigma delta converter. So that way, you use two capacitors. That is one integrator. There are two loop means two integrators will be there, two capacitors. Capacitors and switches will be there, and then we will be on comparator will be there. So using CMOS op-amp, switches, capacitors, we have built one. There was actually one company, MC in UK. So they give you actually array, very programmable array which contains CMOS op-amps, switches, programmable capacitors, resistors. So you can one tool has given. Using the tool you can lay out, and then we have built one. Okay. So like this, switch capacity was done. Then this comprehensive book on switch capacity already mentioned you. Then at the same time, what happened is this evolution I am telling you. Switch capacity again, side effects are there. What are side effects? You need a clock. Then something known as clock feed through is there. Because we are switching all this parasite capacitances will be there. So that that clock feed through actually appears as offset. So further offset compensation we will do lot of things. Or gain compensation we will do lot of things. So that's why what they thought is to avoid all this anti-aliasing filter and smoothing filter. Why don't we do in continuous time? Actually, this is where research comes. What is research? Research. Something, you thought useless. Then you went on forward. Then you find a block. Then, you again will go back. See, can I change something now and improve? You see, actually, FET was invented before bipolar transistor. FETs were used as switches. So they thought, why don't I use a switch as a resistance? Which in fact very classic papers were there using MOS transistor as a resistor by controlling gate voltage. So continuous time filters have come. See, this how words also have to be kind. Hype should be there. In research, hype should be there. Hype is not there, nobody look at your path. Continuous time filters is there. Then this you needed. Then you need a control voltage. Then actually this outstanding work was done by Swedish. Columbia University. Then how to bring that resistor to the desired value? Control voltage have to do. So they have built a beautiful control loop using this phase lock loop. That is when they put an oscillator. And oscillator they tuned. And then this filter should be aligned to that oscillator. Till the time it keeps on. So automatic tuning loops were there. So beautifully they have designed. Today actually most of the fellows use continuous time. Then still people were not happy. Because power supply voltage is coming down. 5 volts has become 1.5. But dynamic range is still speech, you are not able to reduce your speech. Speech level is same. You will shout means your shouting is the same level. So signals have not changed. Power supply voltage changed. Now how to tackle that? So then they thought, why don't you work in current mode? Current mode. Beautifully, how bipolar transistor was invented, tell me. It is a current mode device. In books if you read, they say send current to the emitter. Collect. Alpha is the current amplification factor. And what is FT? FT, that is current. That current amplification factor falls off at frequency. That is far more than your common emitter, the beta cutoff frequency. So that is what we have done all along. We have been using it as a common emitter mode, telling current gain and all that. Then you have lost the band. But now once RF applications have come, people thought current mode is the best mode. So actually a lot of devices have started this and they have built one a chip known as the CFOA, current feedback op-amp. So that means they will have something on a current conveyor and on a buffer, on an amplifier. So the beauty of that is the bandwidth is independent of gain. For normal 741, what happens is, suppose gain is 10, bandwidth is 1 megahertz, your bandwidth becomes 100 kilohertz. Whereas current feedback op-amp, it doesn't bother what is your gain. It has constant bandwidth.
So the gain bandwidth product doesn't have any sense.
No, gain bandwidth comes. But this internal dynamics is such that this it doesn't come into picture when you analyze the transfer function. So current feedback op-amps have been sold extensively by analog devices and all. But then what happens is some technologies won't further progress. Current that 844 is there. Now you see most Indian papers, Indians keep writing the same thing on this DVB-CCC22, like this, so many devices they are imagining. They are nothing but combinations of OTA, current conveyor, and they name a big name for that. So nothing has been changed actually. Instead of using 10 components, he is telling only one symbol it gives. But actually it is having 10 components inside. In between, OTA has come. What is OTA? Operational transconductance amplifier. You know, switch capacitor filters, when they started, they thought why op-amp is required. Op-amp, you know how it was designed. It was designed to drive very low resistance, 100 ohms. 75 ohms is the output resistance of 741. But switch capacitor don't need, because maximum capacity anybody can do on a chip without paying in 100 PF. 100 PF you have to drive and some high resistance load. Why do you want to have a complicated op-amp? So that's why they say OTA. That means it can drive only very small load, very small capacity load. OTA. In between, people have thought of GM also, transconductance. GM. So GMC filters have come. OTAC filters have come. So like this, now various options are there for you. So trade-offs are there. Like you have to see based on bandwidth requirement, power dissipation. Then all these things, noise. How do you reduce noise in an op-amp, CMOS op-amp? You use P-channel input instead of N-channel input. So today these are all the guidelines. Because P-channel transistors have low noise than N-channel transistors. So that means these are the fundamentals you teach to children. Because when you have to become a good designer now. Okay, so this so current mode signal processing was there. Then now it has gone. It is not there. But again, we don't know after
research may come. The
Correct.
old thing.
See, when there is no alternative, Tina, you know. So this then recently I published comprehensive book on analog active filters because switch capacitors I have done. Current mode I have published a book. Then but what happens is every few years technology is changing. So the same book will not be useful after say 4 years. Then one in fact reviewer asked me, that one of my friends asked me, why don't we add a chapter on applications? Theory and all is fine, but industry will be more interested in disk drive read channel IC. So many people have been, papers have been published because it is one of the challenging problems in analog design. So like this, one special chapter I have introduced, totally on application. On application of today, a lot of ideas like FOM they ask, figure of merit. For example, you want to publish, the first, these questions I can ask you. Simply I can ask, is others have not given FOM. Figure of merit, because instead of telling gain is more, bandwidth is better, from power supply rejection ratio is good, and all this, there should be one common universal measure which tells you. Again, FOM also, you can, there is one beautiful Indian thing, beauty lies in the beholder's eyes. So, one fellow has written a book, Holmes and Heinlein in footnote, using a suitable figure of merit. Anything can be told to be good or bad. So, figure of merits are also bogus. But what happens is reviewers will ask you, figure of merit, you have to give. So, we have to say, so that's why we have to say which figure of merit. There are some 4 or 5 figures of merit. Okay, so they will ask all that. In fact, reviewer may ask, is my figure of merit has been cited or not? Okay, so this comprehensive book is there. Why I have written this? This is for my own, because I feel I have something to do to these students. I have to teach them. Every teacher views things different. I will ask you a simple question. Is anybody digital signal processing? DSP?
I have done something, but long back.
I give you one problem. Long back. Okay, doesn't matter. Yes. For example, impulse response. What is impulse response? Many DSP guys come and before I am a DSP expert and all that. Ask what is impulse.
FIR.
Response to the.
That is okay. No, what is that's why don't tell me story. What is impulse response? That is the question. You have to give me the answer. Then one student tells you impulse response is response on impulse. My grandmother knows, where should I ask you? Tell me what is the physical significance of impulse? Anybody teaches? You ask your DSP teacher, nobody knows. That's what I found. I was very lectured by Antonio in Concordia. Antonio is outstanding fellow in digital filters has written a book on all. So he used to explain in the class.
Okay, so sir, please tell what is the physical meaning of the impulse response?
I will tell you. I am coming to that. Now suppose like this. What happened? I pinched you.
Yeah.
Did you feel for some more time?
Yeah.
That is what it is. That means, the memory of a system. Suppose you give a step, immediately it will respond, right? Then slowly, that means, it decays after infinite time. That is important. So,
IIR means IIR, infinite impulse response.
infinite impulse response.
That means there is some
No,
level of.
that is also wrong. See, finite impulse response means you are simply telling this 32 tap filter. Means 32 samples only impulse response. Infinite impulse response is there. IAR means impulse response, you are not restricting to any number of samples. That means it will remember the input which you have given for life. Okay, another question I will ask you. Mechanical engineers are there? Mechanical engineers. Those days we used to study, Timoshenko and Young, book was there. 10th of
Strength of materials.
I asked one, first
principle.
question in first chapter is this. I have put this on a table. Prove that it is at rest. That is the question. Can you prove? How many mechanical engineers can answer that question? They seem stupid question. No, that's what another concept should be taught. You know what it tells you? This, weight is there. Weight is there, no? This weight is a force acting in this direction. Unless there is a counter balancing force, it will not stay at rest. What Newton's law says, unless you move it, you cannot move. You have to apply external force. So what is that? Is reaction. That means, once you put something on the table will give reaction, which you may not see with your eyes, but it is there. Otherwise, it will have moved. That's what happens when you go to moon or somewhere. So, what I am telling you, this concept, will be learned only by hearing to good teachers. Or people who have learned from good teachers. Okay, so that is what teachers are. So, like this, then this was one track. Time is there, no?
Time is there.
So, this was one track. This is my passion, analog filters. That is, when even today I get papers for review and I keep looking at CAS, part 1, part 2, Journal of Solid State Circuit to see how the technology is going. Then, I know I write comments on some papers also. Because what happens is, many of the I have seen, one recently some paper has come. They talk as though they have discovered something, which was found in some 20 years ago. So, as a member of technical community, I have to inform the readers. People fellows is already. So then they published that. That is came from a very big group in Europe. That is, of course, others are claiming, we are not aware. We thank the author for bringing to our kind attention all this. But actually, they may be knowing also sometimes. Okay. So the only thing is, they use the idea, but they do it in the contemporary setting. That is, what today, if you want to implement, we say fully differential, I have to do. I would have done single-ended. He says today, fully differential. Some gimmicks they would have done, but basic idea is not same. So I keep writing comments because it is my duty to tell the posterity that don't be misled by this fellow. He has not invented that much before the ideas were. Okay, so then it happened that one I was in 80, after I came back from Canada, there was an executive director named Jayasumara. One day he called me, Anand Mohan, up, ನೀವು ಒಂದು ನ್ಯೂ ಎನ್ಕ್ರಿಪ್ಷನ್ ಆಲ್ಗರಿದಮ್ ಮಾಡಬೇಕು. We have to do one new encryption algorithm. Then I said, I don't know, I am not familiar with the field. There is already one fellow is there, one of my colleagues is there, but Raghavendra, one fellow. Hey, don't talk nonsense. How do you do? I don't care. Do it. Then we see that was a challenge, He said, Army we have to give to Army this generation encryption equipment, which will survive for 10 more years. Because any algorithm you design, it should survive for 10 years. Because what happens is cryptanalytic abilities will be increasing for the enemy. Supercomputers will be going on. Now you see quantum computers have come. You can't say, whatever I design, 1 year it is good. So what is the use? Because equipment, whoever buys, suppose you buy some cell phone, you want it for at least 2 years. Otherwise, why you should buy? Every day you can't buy. So that's why, he told me, you do whatever you want. Then he told, if you want to take one more guy was there, Dr. Rambuck. That is, he was an LRD writer. Afterwards, he was in K. Then, afterwards retired from K. He came from Canada, Dr. Rambuck.
Power electronics textbooks.
No. This fellow is good.
He's in communication.
Business owner. So, this, then he told one more young guy you take Shashigiri. Then we have to read, I have to read from fundamental papers in proceeding vertically. Then he said, if you go and meet directly SSIT in Delhi, scientific analysis group. Then, we met. Then I told, this, I understand you design new encryption algorithm, so can you tell us what has to be done? Then he said, you have come for here, you please go and read this Dippy-Hellman paper. It is one of the outstanding papers. Dippy-Hellman papers. Pursuing of IEEE. There is a story for that. It was sent, it was accepted by IEEE. Then this company objected. IBM objected, telling, no, it is dangerous to publish that because it tells our secrets about all this. Then IEEE said once it is accepted, nothing can be done. Then we printed one of the outstanding papers. Each line is a parrot actually. So, so what you do is you have to read between the lines. Then I came back and I thought, why don't I have designed new one. So we started. And within 6 months we have designed. Then so massive scheme it was. It could not be implemented in normal conventional logic. And FPGA is not there. FPGA has not come at all. Only microprocessors were there. 80 was there. Then what happened is then we went to our boss, director Prabhakar. He's the VLSI boss. Then he told we will do in our foundry. Then whole CAD was done in IEEE, Bengaluru. Semiconductor complex. Chandigarh was fabricated in this, it was a 3-micron technology and massive hardware. So, it was 8 chips were there for each encryption. So we built all the chips. Then I have visited every place in Western India. Because designing is not sufficient. You have to fabricate. You have to get the system validated. So SSIT validates our algorithms. That is, they will see what is the complexity of this. So that 10 years it will withstand the cryptanalytic attacks. Because supercomputer, you can estimate what is Moore's law and all, say by this 2035, this is the capability. So you must build something which is greater than that. So they evaluate all that. So they have cleared. Key management was cleared by Joint Bureau. And they gave the top grade. That is B1 they call, B1 grade is there. Then this produced and it has been installed. Then all our ITA team, there are around 30 people who used to go and sleep in army buildings, our buildings. We have built nodes. And I have traveled Rajasthan, Haryana, Punjab, then terrorism was there actually. Punjab terrorism was there. Every day we used to visit 3 places, J&K. I visited, this Ramchandra Peak, then this Jammu, Dayal Chowk, Mamun, so many places. Every place our team used to go. And complete equipment was indigenous. Microwave towers, ours. Microwave radio, ITA. Switches, ITA. Voice switch we had, switches, ITA. That means everything was indigenous. Then, when we started the first link, so much happiness was there. Army wives used to come to the nearest node and talk to their husbands who are working in some other nodes and there. And that Jawan would say, my ear is getting tickled because he is hearing his wife's voice. That is how And we used to visit the site, we sometimes we used to visit 3-4 stations and we used to come at night 11 o'clock. That fellow used to ask me, Jawan, आपका खाना हुआ नहीं, मैं अभी 15 मिनट में खाता हूँ, 15 minutes, he used to cook for us. So the type of affection. And every time I used to go, they used to learn from us, if this problem comes, what we have to do. So what happens is, then afterwards what happened, lot of, every 10 years we have to change the design. And a lot of new requirements have come. Because once, the earlier days only PCM exchanges were there. 2 MB streams, 34 MB streams. Then what happened? IP came. Cisco routers. Then how do you encrypt the router traffic? We have to design special methods. Because what happens is, this in the encryption system design, for example, SSIT tells that no known text should be ciphered. Known text means suppose you have IP packet. You have like this source address, some header, source address, destination address, then payload, some checksum, something. Source address, destination are coming for every 1544 bytes. So that is working as known text. Because same thing we are ciphering using different parts of the stream. So he said, nahi cheta. That means what you have to do, you have to encrypt only the payload. Should not encrypt the header. That is what transport layer security. Okay, whereas if you see commercial one, if you see VPNs you take, there's a tunneling. Tunneling will encrypt everything. Very risky. But only you are thinking, only from this office to this office it will go. Transport layer, you strip off the headers. But no company will issue the pressing code. What is this? It says, says, no known text should be encrypted. So like that, lot of customization. Then satellite encryption was there. Satellite, because all we wanted were this VSAT, very small aperture terminals. Encryption of speech. So there, different problems will come. Because DAMA systems were there, PAMA, the demand, multiple, so many types are there. So for all this encryption has been done. Then you have to think of about this, for example, what happens is sometimes TCP IP. TCP IP, there is something retransmission is there. Suppose, your packet is having error. It tells you, please send again. You should not cipher the same thing using different parts of the sequence. These are all the rules. So what happens is many specialized design. Then satellite encryption, another problem is satellite delay itself is a problem. Because when I send a packet now, it will be received only after
250 milliseconds.
round
GFT
delay. So to keep, that means everything you have to customize. So we have built systems for Indian Army for all possible. Up to STM1 we have done. STM1 is 155 megabit. STM4 is 622 megahertz. So that means all the interfaces, some beginning we used to do ourselves. Afterwards we take from Tejas networks. Tejas networks gives the dabba. You tell them, you only have to take fiber and then give us only clock and data. We mess it up and give you again multiplexing and do. That means we have developed intelligence companies also. Everything should not today outsourcing means what? So many of these interface equipment we bought from companies. Then encryption is our specialty. So several ethics made IT foundry. Then what happened? I am telling you Indian technology, how it messes a picture. You know, semiconductor complex has died. Then, because it was dead because of ASCON, I tell you, terrorism was there. They burned the foundry. Then, how to meet the requirement? Then we have done in our own foundry. Then after that, semiconductor complex again was, this government told 200 crores will give. Top. They don't want. Then ISRO took. It's a shame on the nation, you know. It's a shame on the nation to say semiconductor complex has to be governed by ISRO. What ISRO interest is there? What government, Prime Minister Post said, you keep quiet and do. Then again they bought second-hand foundry. Who will give you first-hand foundry today? You are 100 years backward in technology. You get first-hand foundry. And second-hand foundry, space will not be there. Suffering. To take off itself it took a lot of time. Then another thing, you Indians have pride. We have pride. Pride means Desi. You want to use made in India stuff. We have pride. So everybody says, 1 micron, that's it. 180 nanometer we are having, 180 nanometer that's it. 20 nanometers you want, what for 20 nanometers you want to tell me? Is there one application in India, here you need 20 nanometers? That means what is there you don't want to use. That is the problem in the country. Users also. That is automotive, car, some electronics is there. Do you need 20 nanometers? So, what I am telling, Indians don't have pride. And that is different between India and other countries. I have seen throughout this 50 years of my industrial experience from 1970 and seeing. So, this was several ASICs have been made for our own country. Then publications. What happens here? This somehow, this, I think Saraswati blesses me always. Saraswati, Allah, whoever I do. Suddenly some idea I get, why don't I write a book? Then I have written this. Then in between cryptography area, actually I developed interest, because necessity was there. Some area residue number systems. I developed interest. So I published 2 books on residue numbers. I will show you the books also. So a lot of papers have come. Journal of Solid-State Circuit and Subcustom System, CSSP, Support System Signal Processing, IEEE Journal of Education. Okay, that means we should encourage Indian journals also. IEEE Technical Sadhana and all. Then I already told, and I was associate editor of PCAS 2 for one term. 3 years I was associate editor. Then CSSP I am editor since past, the associate since 15 years. And Sadhana since 2 years. IEEE Journal of Education for 2 terms I was there. No, somebody else is there. These are the 5 books. You can go to Amazon and see.
So what is the name by which you are publishing? Because I was just searching that Ananda Mohan. Okay, Ananda Rao is what I was trying to search, so I didn't get it, that's why.
Ananda Mohan.
Okay, so residue number systems is the recent one. Then this first version came in Cuba. That pink one, first came in Cuba. Then switch capacitor came the first one 1995. Then current was inner passing in after I came back to India 2002 I think. Then recently this one fellow invited me, why don't write a chapter on residue number systems. This Stavritis and other Meher, Rajiv Kumar Meher. So
Mayor from RGC Rourkela?
now he is there. He was actually in Singapore.
Acha, acha.
And Pradeep Kumar Meher. He is a very good fellow in DSP. He was he was having health problems, so he came back to India.
You're part of CBA.
There are so many Mehers. Pradeep Kumar. So this fellow invited me, why don't write a chapter on residue number systems. So I have written a chapter for him. Okay, now I am writing a book on post-quantum cryptography because that is the latest crazy
Latest
area,
trend.
no book is available. Okay, but it takes time because this, I have to collect information and today technology has changed so much,
Yeah.
and I have become old also.
Exactly.
Because if I sit for more than 15 minutes, I have to walk for some time.
Yeah.
Back pain and all.
But still, sir, you have the zeal.
Zeal is there. That is there.
So that is commendable.
So that's what.
Your body become old, but you are still young.
So
zeal is
that
keeping
is
you
there.
alive.
Because
So
why
everything starts from here actually.
Yeah.
No, that's why. For example, that post-quantum cryptography. Even today, we have industry projects in CDAC. Because now technology is changing. Post-quantum cryptography are entering. Quantum computers still not there. Only very small capability. Google and all have got. But suddenly something may come. Some 10,000 qubit computer may come. Then all your existing Internet Explorer will be open. Then you should not lift your hands. That's why post-quantum cryptography has come. And this is fully mathematical. This is based on lattice theory, coding. So many of the engineers, today what they do, they go to GitHub and download the code. Nobody knows what it is doing. So sometimes they say, come and start working, they come and tell me, said, you idiot, you should first understand what you should do. Yes, that's why Kavi Hridaya, Kavi Hridaya is what is in the heart of the poet. That you have to reach, Vimarsaka, critics should reach the level of the poet. Poet will not come down to, like our cinema songs now, they are coming down to our common man. That's why our nonsense they are writing. Why olden days, we used to have difficulty in reading some of these old books, because you have to put effort to do that. Today we don't want to do effort. That's why all writing rubbish they are. That society I am telling you how it is degenerate. So these are the 5 books and one more you get Sarti. So these are all details are there. And royalty, we don't write for royalty. Royalty first time he may give. Some $600 or something gives. Afterwards, not there. But some publishers are very good. For example, this Barkhoud, honestly he tells you how many copies have been sold and he gives 10% of that. But for them, okay? Don't give to Indian publishers. Because Indian publishers never tell you what he has sold, how much money he has got, nothing. And because of my reputation, when I say book proposal means, nobody will ask any question. Because reviewers automatically will be arranged. And because of style I know, everything I know. They ask you to send the table of contents and one sample chapter. That they just read and then they give suggestions based on table of content. Is it sellable? If so, for what level? Is it for students or is post doctoral students or something? All these questions they will ask the reviewers, So based on that they push the price and all that. Don't do it. So IEEE, what happened? I was a senior member in 80 itself because I was already 7 years member. But no, I was not a member. Directly.
Sir, you want to take some break for 1 or 2 minutes?
Yes.
You can take a break.
No, I can stand. But you want to.
No. No. Okay.
Maybe now it is coming to end almost.
No, not for that. Just
No.
because it has been 1 hour.
So directly a senior member when I was in Canada. Okay, 1980. Then because Swami told me application fill karo and I will do. Then I became fellow in 2005. And you know who are the references for me? Atre. Yeah, Atre, you know, scientific advisor, past scientific advisor. Then this fellow, Surendra Pal of ISRO. Then 3 eminent fellows from Canada, that is Antonio, Ramachandran and Swami, because they should belong to our society, who know my work and all that. So I became a fellow. Then life fellow, what is the rule, you know? My service in, that is my membership in IEEE plus my age should be 100 years. That is the formula. So, the only advantage you get is your basic membership fee you need not pay. But journals not have to pay. For example, I have been a CAS member since 1980. Journals all states of course, because I am more interested in the how ICs are being made. Okay. So, because that is my those two. Okay. And I keep, nowadays I stopped getting printed versions because I have to waste paper and all. So online available. So editorial assistant I mentioned, you know. So all these journals I am now the senior associate of Sadhana, that is Indian journal. You know, all junk is published now in India. That is from all the colleges. And they simply sending what we have to review, you know. So I don't give cursory review. Like you know, this paper is useless, I will not say. I will tell them how to write also. Many of the young fellows may be there, you know. For example, many people don't know this, how title should be there, how keywords should be there. And they put doctor for a professor, doctor and others are not required. Because at least they should read once some IEEE transactions, you know. Then keywords are nonsense will be there. Because keywords purpose they don't know. It is for the searching machines to say your paper is relevant or irrelevant. You just give machine learning, use keyword, in 1 million papers will come in machine learning. You should say for which application. So then they don't know how to give references. And you know, most of the time they give all Indian useless references published in open access journals, which are never reviewed by anybody, which are paid journals. So what happens is there is total degradation in there, and you know they want only they say numbers. They want to show their professor HOD that published 10 papers. Has anybody cited? Because you know there is a caucus actually. That means you pat me, I pat you, like this. My idiotic paper you used refer. Your idiotic paper I refer. So like that, there is a citation index is there. And these fools are believing also. All the directors of the colleges who give promotion, they are believing all this. There is an ISC what they say. They say, you know, marks are there. Full paper in IEEE transaction, 2 marks. Correspondence, 1 mark. Conference, half mark. Conference was a reputed conference. You design automation, they say 1 mark. Because it is considered the best conference in the world. So like that, they have got a Indian conference, 0 marks. That's how, you know. So, and another thing is there, you know, why abroad, you know, the research is different, is a tenure track. After 5 years, you will be kicked out if your marks are below certain value. Not like lifetime appointment here. Here you join and then you can stay for lifetime whether you know any new subject or not, or whether you teach or not. So that's why you know that there is one proverb in Telugu. Unless you ask your mother won't give you food. Suppose child unless she tries, you know, mother till that time mother thinks she is not hungry. Child has to ask him. So organizations have to demand excellence. For example, all my engineers, you know, in many times I tell you, some software guy big pose they have to pose. Then I have to sit by his side. Just you know, when he is doing this, you know, just say, and what are you doing? Then he says, I am writing some code for something. Show me your code. Then he used to show. Then I tell him, you are stupid fellow. Why? They don't know basic coding practices. Like, you know, first you should tell at the beginning, you know, what is the code doing? Some header, writing procedure. Then what are the inputs? What are the outputs? Then you know, you should put every 10 lines some comments by side you have to write. What is that module doing? Because what happens in industry, suppose you resign and go, I have to lift my hands. Because some junkie will write some 10 kilobytes, something he writes. But once he resigns and goes, this, if I give it to somebody, he says, this Brahma also cannot understand. So that's what happens, that is that culture has to be built in the organization. How many times bosses go and sit by the side of his and find out what he is doing. Design reviews are not conducted, I am telling you. Sida also you to ask. Design, suppose somebody asks to design something, then design review should be conducted. Design review should not be again your tadas only. Chemchas will be there, they say, oh, bahut acha bana. You should call people from other groups who may be idiots in that field actually. Because sometimes what my experience is different, your experience is different. You will think, I think this some question you will ask, which based on your experience. Then you should answer that question. You should record that. You should answer, and you should say whether it is relevant or irrelevant. And next design review you have to present it. That is how it is. In industries it is done. Abroad, engineer's notebook is there. Suppose you want to apply for patent. How do you say? Somebody may invent the same thing in before 2 hours before. How he defends it? Because the boss is supposed to write every evening in the diary what is the work that has been accomplished and sign. Engineer as well as the boss. Many companies do that because sometimes the intellectual property is so precious. So all these good practices we should. So this all this. Then I am general chair for IEEE, this APCOS, Circulation System Asia Pacific. Okay, so myself and Govindacharya from Hyderabad, he is there. Then Prime Minister General Chair I am since so many years. Then Public Infrastructure, this is conducted by Minister of Information Technology. Since past 6 years or 7 years I am there. This year I am going to be held in September. But I am very strict and I don't care for numbers. Last year, more than 300 papers came, 9 were selected. Because if it is nonsense, this year I tell you, 450 papers have come, all on machine learning, almost. All useless, because people don't read even what is the conference about. Like T-leaf, some detection, or kidney disease problem, something. All this nonsense, retina, something. Full worst. But as an IEEE, you have to write comments. 2 reviewers should be there and each reviewer has to say why it is relevant. So we have to write for each fellow some. So, but what happens, we have to be very strict. I don't care if only 9 papers are there. Then advisory role. For example, I am a member of Broadband India Forum. For example, a lot of questions will be asked in Parliament about all internet security, all this. So, these are member of them, they will ask me. Then Data Security Council of India. Then Bureau of Indian Standards. Because recently they wanted e-learning on standard to be released in India. Okay, so I have participated. Then AI for cryptography. This is PSA, Principal Scientific Advisors Project. Because the government asked him, this cryptography, can it be used in AI? Can AI be used in cryptography? So, this myself and one IIT Madras professor was there, a very eminent professor. He is head of the Center for Artificial Intelligence. Okay, so we have a committee and we are supposed to give we have given. That is available in the net with the PSA, Principal Scientific Advisor. Now, this will come to this. What has improved in India? Because I have been here since, born in 1949. Okay, small village. So, I have seen so much. So, I will tell you what has improved is communication has improved. When I was working in, I told you, ASCON project in Army, there was no communication. If I have to talk to my wife in Bengaluru, I had to wait for I had to book a train car and wait night up to 12 o'clock. Then I could not hear also properly what she is talking. One man has changed the whole thing. Who? Tell me. Who has changed? Putroda.
Semiconductor.
Sam Putroda. You know what I mean? Sam Putroda was given a mission by Rajiv Gandhi. You may blame Congress for all these things, but they have done good things also.
Yes, yes.
Very good things. Putroda, you know, what he has told is, I will use Indian engineers. I will design here. I will develop industry here. So he told, there are first model he has given. Software will be done in Delhi. Hardware will be in Bangalore. Two separate groups. Then, he said 1,000 line exchange you have to do. So 1,000 line exchange, this started. And he recruited people from all IITs and local colleges and all. Then it was getting delayed. Then what he did. But people were putting fire in his pants. That is, simply are telling cartoon book stories, all this. Then he said, 50 line exchange I will release. So he released the 50 line PABX first. And then he said, I will not give it to ITI alone. I will give it to 6 companies. Then he gave to Instrumentation Limited quota. Like this, some companies who don't have much telecom experience, he has given Keltron, he has given Kerala State. So like this, he said, these people will be given full technology by SUDOT and support. And then the whole country has changed actually. Then he has told all Kirana shops you have one STD phone. Kirana shop, in those days, we used to go and pay 1 rupee and then make a call. So the single person has lived his life. Then what we did to him? We kicked him out. That is what we do. In India, this, you don't have any common sense. You don't have any respect for merit. Okay? So, Putroda has gone. Afterwards, what happened? CDIT is continuing, but now with all these truncated budgets and all, another thing. This point also is there. I think it is coming later. Another point. Now mobility has improved. Air travel. Earlier we used to travel by train to Delhi and Rajasthan and all that. All desert areas and all. By Jaipur I used to go by train and night and then do some work. Again come back. We used to wait in Delhi to get return ticket. All this we used to do. So now mobility has improved. Best in railways. India is best in one of the best railway network, especially in desert. Nobody is having that experience. India has experience. For example, go to Rajasthan, you will know. Even desert warfare, India is number one. General Sundarji is a consultant for all this Afghanistan, Iran and all, because he has such a vast experience how to use camels, how to do the desert warfare. So, like that, we found solutions for all these problems. Then exploitation of natural resources. When I was a child, how many companies government has, Nehru has started? Hindustan Copper, Hindustan Zinc, Hindustan Aluminium, so many companies. That means they know natural resources are there and they have to be exploited. So how to use those existing? And Keltron used to make quartz crystals. Andhra Scientific Company used to make quartz crystals. That means electronic components used to be made by EECIL, all resistors, everything, capacitors and all that. Power transistors used to be made by EECIL. So that means total connectors used to be made by one company in Bengaluru, this Amphitronics. That is Amphenol, connector company used to do. Cables used to be made in India. PCBs and all later came. For my PhD thesis, I made my own PCB. That is, someone told me this, some acid you have to put, make, and then we used to print the pattern. Then we used to go to workshop and get the drilled. Graph sheet I used to draw the pattern, then drill, then components, we used to, after etching, I have to etch myself, then solder it, test it. There is one beautiful thing, if you see IEEE spectrum you read, spectral lines, last page you read. One fellow writes, Robert W. Lucky, he writes, the smell of solder on the soldering iron intoxicates me. Today, who is interested in hardware? Nobody is interested in hardware. But we used to enjoy. Debugging, is a great, now today people start scaring, problem has come. Actually, no, you debug only you learn. If there is no problem in life, how do you learn anything? Problem should be there. Like Kunti tells, Mahabharata, Kunti tells Krishna. Krishna tells, okay, everything is fine, I will take leave. Then she says, no, you give me troubles.
Remember.
So, engineers also, you should welcome troubles. There is nothing like perfect design. That's why continuous evolution is taking place. So technology, how it is developing, we are not satisfied with anything. You should not get satisfied. But only what you do, if you get 80% satisfaction, publish it or produce. 20% you should not leave. You should further work on that. That is incremental productization. Peter, I told you example, that's what. He told, let us not wait for 1,000 exchange. It may not come within the stipulated time. So, what I should do? So that's the management should have that sensitivity. 7 educational institutions have been developed. Village, we have reached village education, medical services, communication, and exports, especially software. Then space technology, atomic energy, and application, electronic transaction. Now, how space technology and atomic energy developed in Germany? Because embargo was there.
Right.
If embargo was not there, we would have been idiots, even now. Because space technology, who tells you how to make a rocket and fly it? You see, some NASA, some old Purana reports are there. People have to read those reports. In that, nobody tells you actually your secrets, no patent, nothing will be there. So, that's why, the eminent aeronautical engineers have to be there in India. Right from Satish Dhawan, so many Martin Narsana, outstanding engineers were there, aerospace engineers. Many of the ISC and tech students need to go to Caltech. Directly first to need to be taken to Caltech. So, this is what that atomic energy also. BRC training program is there. Every year they take 100 engineers. Very difficult to get entrance into that. And they train them for 1 year in all areas of atomic energy. The electronics man doesn't mean we should not know about control systems or something else. Everybody should know about, if they ask you what BRC is doing, they should know 100%. Because tomorrow you may become director of BRC after 15 years. Should not say. Companies also, I tell you how company BEL, Bharat Electronics, how it is progressing every year. Tell me. Every year, some 10,000 crores more, something it will add. Why? That because they know what new products you have to introduce, how to canvas for them. They, many people want to sit in actually Ministry of Defense, Shana Bhavan. They write the RFPs, customer proposals. They brainwash the customer. Tell them, aapko ye chahiye, wo chahiye, and all that. And then that's how they have to do, But they will not tell cock-and-bull stories. They are showing results also. That means so much marketing effort they have to put.
Our brains definitely act like demanding customers, constantly ordering up desires and...
Okay, so this is how companies should change. So this waste atomic energy, that's why all this bomb, how can you make? You can't announce or nobody describes. This is how internet is not available. You try how to make an atom bomb, a hydrogen bomb. So technology has definitely developed. Now what we have missed? This is one. So we are great starters. That's what Arambha Sura they call it. AI was started in 1980. Do you know? Artificial Intelligence. KA. What is KA? Center for Artificial Intelligence and Robotics. They have brought Professor Vidyasagar from this foreign University of Waterloo, Canada. Then he started that.
KR means you are referring
Center
to
for Bengaluru.
Yes,
DRDO lab. Center for
Raj Bhavan
Robotics.
Yeah, so because there was a department KR in IIT Delhi also.
No, that is okay. That is research in electronics, applied research. So, KA was started. Artificial intelligence, this requirement was there by army. And they said, special thing, because they know in warfare it will be useful. Okay, so then we know nothing was done afterwards. What you have done? You have kicked out that fellow. That is what our Indian procedure, actually. A developer, then you kick out. Because then Paul Raj was brought. He was again going to this USA has gone. Okay, so that means we don't want excellence. That is the problem with India. Sustenance is never
I
thought of.
think, sir, you can skip this because it is being recorded.
Huh?
It's okay.
Is okay?
Practically fine. These are all known facts.
Okay.
Very well known public domain facts.
You can delete it if you want. This is my opinion. Now you can
Sure,
always
sure,
tell.
no problem.
They will not jail me. So sustenance is never thought of. All electronic components, telephone, transmission equipment, switching equipment used to be mass produced. Then when mobile telephone and internet have done, we were sleeping. You see, telephone companies should quickly jump to make collaboration, make cell phones. Why you have not made? Why you have not made an IP router? We have not done. Juniper was there, Cisco was there. We could have collaborated with them and made a router. We have not done. So that's one. So mobile telephone, internet have gone. We have to do properly bits. Then the same thing is semiconductor. Semiconductor, I told you, Chandigarh was there, CDL was there, VL was there. VL was making 40 series, CMOS inverters, all gates and multiplexers, everything was there.
Even lot of transistors. Like I remember in my very early age, we used to buy Bell transistors.
No, that's what I mean.
Yeah, so that was really
So,
good.
even CMOS RCA family ICs were there, CMOS ICs. Then in fact, for defense, they made one analog chip, very complex chip from SGS semiconductors, known as balanced modulator, because for FDM and all required. So, one of my colleagues was head of the Venkateshwar, he passed away. He was in that UTL Telecom, UTL training center there, VLSI training center, he was heading that. So, then the whole thing is closed actually. Because they said demand is not there. Because VL says if line item should be 10 crores, otherwise close this up. That's all. Because it says, small, 1 lakh, 2 lakhs and all, please don't bring. You should have line item minimum of 10 crores.
The same thing has happened in the passive market.
What?
There is nobody who manufactures resistors or capacitors anymore in
That's
India.
right, that's
That
right.
time we used to
Earlier in my
earlier
childhood,
Keltron and all of those people, Uptron, Keltron, everybody used to make all those capacitors and everything.
No, now nobody is doing. I tell you one thing. Suppose you call a fresh engineer today and ask him, tell me what is the value of resistor. Can you tell me? Resistor color code.
Color coding.
B.B. Roy of Great Britain.
Nothing. Then again, mathematics also, I tell you. Suppose, tables were 19 square. How much?
Less than 400.
361. How do I know? I have not calculated 19. But memory you should have. That's why I asked you to mug up tables in your childhood, Or at least, there is one joke I tell you. One professor was there in a class, He asked this one question. What is 17 square? Yes. Then one fellow told 289 immediately. Then he said, no, what did you say? He asked. In between he calculated. So, that means there we used to use the brain. We used to train the brain. Childhood, Many times, procedures, I'll give you an example. Square root, you know how to find square root. Procedure, why are you doing it? Nobody tells you. That is what they say is, first procedure you should know. Once you know same things about square root, I teach you in SSLC. 5th standard also I have taught you. But SSLC fellow, we should explain what he is doing and why he is doing. Because you ask it to implement it in, suppose a square root algorithm, ask it, yes, this VLSI fellow to implement. Can he implement? Because they have been taught in decimal. And you have used your brain. Can you use it in hardware? No. You got my point. But today people are telling decimal computers. Some fellows have started. They don't reach why, human brain, you see, why it is faster. We work in, it is slower as well as faster also. You know, human brain is our, you know what is the fastest in the world? Manas. Manovega. Suddenly I can go to 50 years behind. I have gone already a number of times. 50 years behind I can go. Vayuvega is next, down. This question Dharmaraja was asked. What is the fastest? Yaksha Prashna, no?
Yaksha Prashna.
That is, no, Manas is the fastest. Okay, so we have to reach the limits of, anyway, so semiconductor, after 3 micron technology, we delayed technology acquisition development, we have second hand competition. Then we now are perpetually backward. You can record no problem next. Oh, sorry, I don't know. So now what I have done for society is, I have been serving for Indian Armed Forces. Okay, then protecting, you know, I am telling you, one equipment is named after me, Ananda. Ananda is a bulk system for Indian Army. And you know, there are so many versions are there. Ananda Mark 1, Mark 2. You know, once one general came to me, all generals are my close friends. They used to come to ITI.